Alright, in right triangle ABC, angle B is a right angle. The measure of angle A is equal to 45 degrees. The distance of AC is equal to 8 square roots of 2, and the distance of AB is equal to C. What is the value of C, the length of segment AB? The segment of AB measures blank units. Alright, so it wants us to round to 2 decimal places, if necessary. So again, this is a right triangle, and for right triangles, we're finding a missing side length, so we have two options, the Pythagorean theorem or the trig functions. So the Pythagorean theorem, you have to have a right triangle. We have that. Two of the side lengths known. We do not have that. We only have one known side length. So let's look at our next option, trig functions. You have to have a right angle. We do have that. One angle beside the 90-degree angle. We have a 45-degree angle, check. And then one side length. We have 8 square roots of 2. So we are going to be using trig functions, and it'll either be sine of our angle or cosine of our angle. So again, we first determine the angle that was given for our perspective. So we have 45 degrees. So this is sine of 45 degrees, and it is not because it was angle A, it is because it is the angle that was given. If that 45 degrees was written here, you would still choose that as your perspective down here. This A right there was generic. So it's just representing any angle. The angle that was given was 45 degrees. So now let's label that triangle. The side length opposite the 90-degree angle is our hypotenuse. The side length opposite our degree, our angle that we chose, is the opposite side length. And then the one touching and not the hypotenuse is the adjacent side length. And so we can substitute this in. The opposite side length we don't know, so it would be the distance of B to C. The hypotenuse, we have 8 square roots of 2. Cosine of our 45 degrees is equal to the adjacent side length. The adjacent side length was given to be little c. And the hypotenuse side length is 8 square roots of 2. So then we're going to decide which of these we're going to use. And we're going to use the one that has little c in it because it wants us to find the length of little c, or the length of segment AB. So we're going to just be working with cosine of 45 degrees is equal to c divided by 8 square roots of 2. Alright, even though this looks like a weird number, it is just that. It is one whole number. So we're going to treat it like that. So our variable c is in the numerator, and it is being divided by 8 square roots of c. Well, I know, like, if this was 20, I'd multiply it by 20 to reduce it down to 1. We're going to do the same thing. We're going to multiply by 8 square roots of 2 so that this can reduce down to 1. So then we would have 8 square roots of 2 here. So we actually have 8 square roots of 2 times the cosine of 45. And that's going to equal, well, c times 8 square roots of 2 divided by 8 square roots of 2. This reduces down to 1, so I have 1c. That's what we want, so we're going to jump over to our calculator. We're going to type in 8 square roots of 2 times cosine of 45 degrees. And notice that they did put in solving for this. Do you want us to solve for this instead? We want it to have the 45 degree. So this equals 8, and that is because cosine of 45 degrees is actually equal to the square root of 2 divided by 2. And that, when you substitute it in, simplifies down to 8. So the value of c, this simplifies down to c, and c is equal to 8.